Alright guys, thank you for clicking on this video. Today we'll be doing another IBMAA SL&HL breakdown. Today we'll be doing 1.5 to 1.7. Okay, these are about exponents and logarithms. These things are essentially reversed operations. We'll be starting with exponents. Okay. So let's see. So firstly, there are 1, 2, 3, really just five most basic things you need to know about exponents and their operations. And I'll be going them down quickly with a brief explanations. So number one, x to the power of a times x to the power of b equals to x to the power of a plus b, because you have a of x and b of x, right? So you'll have a plus b of x timing together if you just count how many x there are, right? And then similarly, x up to the power of a divided by x to the power of b will equal to x to the power of a divide a minus b. Oh, that's awkward. Minus b, I apologize for that. Right, and the last one, x to the power of a, and then bracket, the notation is very important. The power of b means x to the a times x to the a, blah, 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 and there are b of this in total. So you have x to the power of a times b, because you have a of b, right? 1, 2, 3, 4, all the way to b, so a times b, right? These are the three operations you can know, and the other two is how does really the two other type of exponent works. So mainly here we looked at positive integers, and here, sometimes you'll also get negative exponents. So that will go into equals to 1 over x to the power a. Right? That's fairly simple. And the other one is when you have a fraction as your power, then you get root to the power of that. So if let's say if you have x to the power half, that's just square root, right? Whereas if you have x to the power of 1/3, that might mean you have a third root of x, okay? So that's the basic operation of exponentials. So knowing this, we're gonna slowly transit to logarithms. So firstly, in your formula booklet, it's actually provided the definition of logarithms. If you look under 1.5, it says a to the power of x equals to b, right? If you have this equation, this means that x equals to log a of b, right? Basically, when you're doing log, you're figuring out a to the power of what equals to b. A to the power of what equals to b, okay? So this is, and there are some important prerequisites to this according to IB. So first, a has to be bigger than 0, b also has to be bigger than 0, and a has to not equal to 1. Okay, why are these happening? So b is very easy, because if a is greater than 0, then a to any power will be greater than 0. Then why do we also limit a? Because once you have negative, it becomes to go up and down, depending on if you're odd power or even power, and that's too annoying to deal with. And at the same time, a doesn't equal to 1, because 1 to the power of anything is 1. Okay, so these are three important prerequisites for us to use logarithm. Whenever you have a logarithm, you have to check if that actually works. Okay, now we'll slowly transit to the other four formulas of logarithms that's actually really derived from the first four exponents that we talked about. Okay, so in your book, in your formula booklet, you need to look under SL 1.7. This is under SL 1.7, okay? And this will take a little bit longer than just exponents. Okay, so number one, log a of xy should equal to log ax plus log ay. Right? Okay, let's look at how this works. So a doesn't mean anything in particular, it just means it could be any number. Log also works with this. So let's look at the last part first, right? We have log a xy, right? Okay, so what does that mean? That means a to the power of log a xy should equal to xy, right? By the definition we looked at above. If you look at here, right? So log a xy, so a to the power of log a should equal to xy. Okay, and what if we do the same thing to the, what do you have? A to the power of log ax plus log ay. Well, first we know that this equals to log ax times to a to the power of log ay, right? This is because of the first thing we talked about exponent operations involved. We're just doing the reverse, right? Now this thing equals to x, this thing equals to y, so xy, right? So I have x on the left and xy on the right, therefore the two equals. Okay, so this is the proof of the first formula. I'm going through this quickly because I don't want to make the video too long. All right. I recommend you more practice. Go look at the Review With Me series, which I haven't fully finished yet, but I will get there. Okay, so number 2. At the meantime, if you support me, I might finish it faster. Okay. Number 2, log a of x divided by y equals to log ax minus log ay. This can be proved using the exact same way, using about, so you put the left side to the power of a, right, and then you put the right side to the power of a, and you can use the exact same approach to finish this, to go down, and this one should equal to x over y, this should also equal to x over y. All right, I encourage you to do this yourself, so we don't waste too much time in the video, and at the same time, this is a really good practice. I think a lot of IB proof questions are similar to this, like show this. All right, okay. Next one is a little bit more tricky. Is log to the power log a. We're just using log a here just to show that any number works. If x to the power of m, right, you have x to the power of inside, you can actually drop the power down to the front, so m log a. Oops, okay, that was my phone. Let me move it. Okay. X. Okay, so we have this logarithm rule, right? This is a second to last logarithm rule that we're gonna look at. So why does this work? Essentially, this equals to log a x times x times x times x, right? Blah, blah, and I have m of x, right? I have m of x. So that means using the first rule, I will have log ax plus log ax and I'll have m of them. Right, so m of this adding together will equal to n log ax. Right, this is fairly straightforward. Last one, change of base, involves a very important concept. Right, you might ask, why do we need to know all these? Knowing the proof will help you to figure out a lot of the questions, because a lot of questions use the same approach as how we prove this question. So you could memorize it, and then it will work if you only need to use it. But sometimes they'll ask you to prove other things, and then you'll need to be familiar with what's the idea of these to easily prove them. Okay, very important to get a stronghold on this. Last one, really important, change of base. So the formula is log a of x equals to log b x over log b y, right? Log b means basically anything. Sorry, not y, a. Right? When you're using the formula, remember what's inside the logarithm goes on the top. Okay, inside goes on the top. Okay, so how do we prove this? This is actually a very instructive proof. So let's look at this a little bit. Okay, so if we have log, let's just start with log ax, right? Log ax means that a to the power, right? A to the power of this equals to what? X, right? A to the power of that equals to x. Okay, now how do I go to the next step? What if I do log b on both sides? Right? What if I do log b? Again, how do I know I need to do this? I don't exactly know, but after you've seen it in this proof, if you need to do it again in some questions, you'll be more likely for you to come up with it. Okay, so let's do log e on both. The hint really is that you have log b there, so I'm just trying to put log b in and then move things around and then see if things cancel out. Okay, right, I have that log ax is the power, right? Equals to log bx. Okay, so if you look at remember the third logarithm rule we talked about, we need to do this, right? We can drop this down. So we have log a, shouldn't put a bracket. We have a log a x times to log b of a equals to log b of x. Right? And this is fairly simple. So now I want to know what log a of x equals to. So I just isolate log a of x by moving this to the other side. So log b of x over log b of a. Okay, so that's my change of base formula. Remember, what's inside goes on the top. Okay, now finally, let's go a quick summary of everything we did today. So we have a to the power of x plus y equals to a to the power of x times a to the power of y equals to a to the power of xy. A to the power of x divided by a to the power of y equals to a to the power of x over y. Right? And a to the power of x to the power of y equals to a to the power of x times y. A to the power of negative x equals to 1 over a to the power of x. And a to the power of 1 over x equals to a to root a. And it's the x root. Okay, so those are the exponents one, and then let's look at logarithm one. So log a of x y equals to log a x plus. Let's move this a little bit. Okay. Log a y. Right? Similarly, log a x over y equals to log a x minus log a y, right? And then log x to the power of m equals to drop the power to the front, m log x, right? And lastly, change of base, log to the power of ax. Remember, inside goes on the top, equals to log bx over log by a. Okay, so this is everything we did today. I recommend you, if you want, you can pause the video, copy them down, and then look at it. Just try to make sure that it makes sense to you, right? It needs to make intuitive sense, and at the same time, really important for you to know the proof. And then when you see similar ideas, know when to look for them. Okay, so this is my coverage on IBMAA SL&HL 1.5, 1.7. If you can, please smash that like button. Click that like button, maybe don't smash it. And subscribe if you can, please. Thank you so much. So yeah, this is my coverage, and I wish you the best on your IB journey or other math course. But I don't know why would you watch this video then. Yeah, good luck, and I'll see you in the next video. Bye bye.